I'm Nam Jae-jeon. I'm really happy to introduce Linux cifsd project at sambaXP. And here is my first international conference. And I'm not native, and I'm afraid that I cannot correct answer about your question. Please consider that point. Yeah. I'm currently working for Samsung Electronics, and I have contributed a lot of patches to Linux kernel since 2011. I have been spending all my time developing new SMB server for 5 years. And this talk will start with a brief introduction and cifsd architecture and outline component and their responsibility and communication protocol. And I will share the cifsd current status, such as performance and stability and compatibility, and share our future development plan after sambaXP. And finally, suggest what we can cover with the Samba team. cifsd is a SMB server for Linux kernel, and it will fill in the blank that SMB server has not been provided by kernel. There are each demos that run concurrently on kernel and user space, and it operates by communicating using NAND-link interface. cifsd supports all SM versions from SM version 1 to the latest version. NTLM and NTLM version 2 are supported for authentication. And we implemented performance and security feature first. So it currently supports oplock release and compound request, copy upload, and signing and encryption. We have been currently maintaining cifsd and cifsd tools on GitHub. And Travis CI is applied for automatic integration test with the latest kernel. And we are leaving the patch on and discussing on the mail list provided by SourceForge. So since the initial work was committed in 2015, currently, cifsd has been developed by 5 active developers, including me, at full time. So I and Sergey are checking overall issue and clean up code for mainline merge. One of the members, called Yoonjae Lim, is working SMB to notify, and Hyunchul Lee is working SMB direct feature now. Before we started this project, we have a few motives for in-kernel SMB server. If SMB server is moved to kernel, can we gain the performance in real? In general, we think it will not use system core. We can theoretically think performance is increased by less context switching, less tail miss, and zero copy. And we can expect to execute a shorter path and less instruction by directly using the VFS and socket API in kernel. And metadata is such as struct file and inode and superblock in kernel can be used directly. So it could reduce unnecessary memory allocation and memory copy. Let's see the result on performance comparison chapter a little while. RDMA support is an old story for Samba. This is probably because Samba is implemented as process model. Context switching overhead for RDMA send receive will make performance regulation on process model. But in kernel, we saw it is easy to implement optimized performance without any constraint. cifsd is a simple and lightweight file share. OpenWRT developer Andy Walsh is trying to merge cifsd into OpenWRT project. He reported that cifsd is suitable for embedded target, which tend to have small flash size. He shared the table to compare binary size between Samba and cifsd. The binary size of cifsd is just 1 megabyte, while size of Samba is 6 megabyte. I heard that OpenWRT users have been using device with 8 or 16 megabyte ROM size. A minimum default install of OpenWRT is already 6 megabyte. Getting minimal package size is still a big priority in OpenWRT because a user can install as many packages as services as possible. oplock reads handling of cifsd is better than Samba. Samba need IPC communication between SMBD process for oplock bring request, while some cifsd can send oplock bring request by managing oplock reads with global data like threaded model. Initially, I implemented all functionality in the kernel, but Steve French advised me to separate into user space. So performance-related features such as SMB engine is going to kernel, and non-performance-related features such as DCRPC and user share management and compilation are separated to user space. This is to maximize performance and minimize kernel memory usage. We call kernel daemon cifsd and call user space daemon cifsd. And cifsd will be activated when cifsd is launched and working by exchanging information between two daemons at runtime. How does cifsd communicate between kernel and user space? cifsd uses a NetLink interface. NetLink is used to transfer information between kernel and user space process. It consists of standard socket-based interface for user space process and kernel API. We specify the following a few command sets to transfer data between cifsd and cifsd daemon. These show the entire cifsd architecture. We provide cifs admin util to store user account and password information to dbPy. And as Samba, user need to write some parameter to SMBconf for configuration. And when running cifsd, cifsd focus thread in kernel will start to open 445 port and listening new client connection. cifsd send global parameters in SMBconf to cifsd through NetLink. If a new connection is coming, focus case thread will fork new cifsd1 case thread as per connection. cifsd1 will receive response, process the request response until the client connection is terminated. This slide shows entire cifsd components. So transport IPC is a component for communicating with the user space cifsd using NetLink interface. The server component is the core part that handles request to response and cifsd server initialize and release. Transport TCP component consists of function to send receive request response through socket API. SMB engine component pass SMB request and make SMB response. And auth component is for processing authentication. The VFS cache component is for file and inode handling, and cifsd can access the local file system via the VFS abstraction component. We implement minimum DCRPC command to connect it with Windows client. cifsd compilation parameter format is compatible with sambaXP1. This is easy to set up for current users who are adaptive to Samba. And we didn't implement all parameters, and we only implemented what user wanted and what request first. We can see the list of supported parameter list in SMB comp example file. And SMB support is the biggest challenge. The smartphone apps still support only SM version 1. So it was difficult to remove SM version 1 because connectivity with the smartphone is becoming important. So I have set it as default disable now and can easily remove if needed for mainline merge.
That's J6 right there.
Performance was measured using IO zone, Fileops, and Bench Opera. We used the temp.fs as a shared directory and measure performance on direct connection between two PC to reduce the result error. And Opera lease is disabled to avoid caching. And we use a kernel CFS client. This is a single writer IO zone result. It showed that cifsd was 4 to 10% faster. As a result of single leader IO zone, cifsd was estimated to perform 2 to 5% faster overall. Fileops is a tool show performance as the number of file operations that can be performed per second. I think that it is good benchmark tool that evaluates overall file system performance, rather than measuring simple read-write performance. As a result, Fileops cifsd was estimated to perform 20 to 40% faster overall. The hard disk sizes grow every year, and there are users who store a lot of files in one directory. The speed of browsing file will be an important factor. So I used ls command as shell to compare file lookup performance. And cifsd was estimated to perform 30 to 46% faster than Samba.
So excuse me, if you're using ls and so on.
Yep.
Question is, when you're using ls and so on for testing, like, are you using the cifs kernel client to connect against that?
Yeah.
So have you also tested, for instance, just with a native Windows client or some direct SMB client tools?
I didn't test it.
Okay.
Yeah. The Opera bench result also show the big difference. This may not an advantage as cifsd working in kernel, but rather an inevitable performance regulation in process model. We have checked the compatibility with various SMB clients. I have tried several tests such as creating deleting file and directory and read-write file and installing many applications and playing video, so on, by connecting devices of respective OS. SMB torture results show 95% pass rate, except the failure for unsupported feature. In case of accept test, it is a 97% pass rate. Some test case fail due to problem with the FS control and so on. And we will fix the rest of fail after sambaXP. And MS SMB2 test suite has difficulty in setting up some feature like Opera and lease and so on. So we decided not to show the result here. Here are our next plan after sambaXP. Now, Hyunchul Lee is working SMB Direct support on cifsd, and we are referencing a lot of SMB Direct code in cifs client. It is making our work very fast. We are planning to share SMB Direct status on Storage Developer Conference this September. We will test it with only cifs client. The compatibility with Windows will follow later. Also, we will only verify with software hierarchy and infinite band NIC. It would be nice to keep the funding of several kinds of RDMA NIC support from hardware vendor to us. Currently, oplock release is disabled by default. There is a stability problem with Windows client. So we are planning to improve it and also fix failure from MS SMB2 test suite. So we are planning to send first batch of cifsd to AKML before joining this storage developer conference. How about make cifsd and Samba running together? Can you find some idea to improve performance of Samba with kernel helper? So Samba and cifsd work together through new parameter of SMB comp. cifsd can be a kernel helper of Samba to optimize performance or something. So at first step, let's co-work that Samba use SMB direct feature in cifsd through IOCTL or NetLink interface. In conclusion, I think that cifsd is a new SMB server for users who want to simple, lightweight file sharing or users who want to more optimize overall performance. And I think that cifsd can be a kernel helper of Samba, and we are ready to co-work and think together. So this is the end of my presentation. Yeah, thank you.
So I'm interested in what you do with incoming security descriptors. When a Windows client does a set security descriptor, how do you store it? How do you map it into a permission on the ext4 or XFS file system?
Security descriptor?
Yeah, when someone sets a security descriptor, what do you set on the underlying, set an ACL? What do they set on the underlying file system?
Sorry, I can understand. ACL. ACL does not support VM. So Samba also support with SMB2 ACL?
Yes.
Okay.
Yeah, we have that because if you don't have that, the SMB torture tests, we have a raw ACL test that you should run against your server when you support ACLs.
Yeah.
The problem is we don't have rich ACLs in XFS or ext4. And that would, if you could combine with us to help Christoph give us rich ACLs in the Linux kernel, that would be very helpful.
If I implement ACL feature, ACL feature, so I will store data to extend the attribute to.
So if you're going to do that, what I would suggest is you look at the Samba code. We could store a common format, so the ACLs that you store we can read and vice versa. That would be basically we use a common backend. So if you want to put that code in, I suggest that you look at our code and model it after the way we have done it.
Okay, I see. Thank you.
How do you interoperate with the rest of the kernel with regards to locking? Share modes, byte range locks.
You are saying RDMA?
No. When you open a file via cifs or SMB for that matter, you can say apply a share mode, which means nobody else can open the file while this handle is open. Do you have a common interface in the kernel to tell the rest of the kernel that you hold a share mode so that nobody else, in particular not NFS, can attach to this file while you have it open? And can you externalize that interface?
Try and simplify. If a client opens deny write, yeah?
Deny?
Deny write. So
Yeah.
you open a file and you set a share mode on it saying deny writes from other openers. Do you implement that with respect to the other processors in the kernel?
You are saying so multi-client open some file and
Yes. So the SMB3 client opens saying, do not let any other process open this file. I want to deny them write or deny all. Does that interact with the other processes running on the system?
Local POSIX client with the XFS process.
I think speak slower. So do you prevent local processes from opening that file?
So we didn't consider that. So we follow the SMB2 protocol spec. So
Right.
there is a share read write delete function.
Okay, so you restrict it between yourself, but it doesn't interact with the other users of the system. So if someone opens it for deny write, someone else can open it write from user space, yeah? Sorry.
The main point why I was asking is NFS version 4 has a very similar concept.
Yeah.
Like, I think they call it share reservations.
Yeah.
And so the question is, do you interact with those? Because as far as I know, the Linux kernel does have a NFS server implementation, which has to implement very much the same concept for share modes.
We didn't consider about that. So maybe some local processor allowed to access sample maybe.
So before you submit to the kernel mailing list, you should fix these things. Otherwise, you may have a hard time. Because otherwise, it works as a simple server, but you need to interact successfully with the other parts of the kernel. So you might have people push back on you if it doesn't interact well with the other pieces.
Okay.
I have a simple comment. Yeah, over there was first. You. Just a second.
Sorry. So you did say something about implementing leases better, or could you elaborate on what you mean about implemented leases better? It also it's related to those questions because KNFSD has different types of leases, and it can be done better in the kernel right now. But what did you do about leases that is different than what Samba does?
You are saying what is different with the Samba?
Leases. How did you implement leases?
Lease. OP랑 lease. Yes. And I implemented these and tested with SMB torture, and there is many test cases in SMB torture.
So you implemented it yourself within the module, within cifsd?
Yeah.
Implemented it? Okay.
Yeah. I think that it is the better point to share some data between NFS. So when we kernel NFS share and cifsd share is the same directory, so can be work with the same data in kernel. So I think that
Yeah, you must.
Yeah.
Otherwise they won't fail.
yeah.
I had a comment about the SMB Direct, so it's awesome that you're developing that.
But I had one comment and one question. Let me just give the comment first. You said you were going to submit it to LKML for review. I'd suggest going to Linux-RDMA first, because LKML, a whole lot of people will either not read it or give you very different feedback on it. Yeah. But Linux-RDMA is really important if you're developing a new RDMA consumer. So the Linux-RDMA list, it would be critical for that. My question around SMB Direct is, you indicated a couple of things about the performance improvements you were seeing from it, and they sounded good. You didn't go into any detail. Is it working well for you?
Yeah, so we implemented only RDMA send receive. Didn't implement the RDMA read write yet.
Okay.
Yeah.
That's all right. That's the way many implementations start.
So we are planning finalize implemented this September. So and we'll share the status.
Okay, so you only have the preliminary coding experience. Okay. Have you found any issues with the RDMA API, the Linux kernel verbs API? There have been a lot of contention about that lately.
So
was it easy to use? Does it meet your needs without standing on your head?
Actually, I didn't implement the RDMA feature.
Yeah, you mentioned it was another
developer is trying to implement it. So
I'm just curious, but the Linux RDMA folks will be very interested in that type of feedback, because this is a new API for them, or a new refactoring of their API, and that kind of feedback will be really useful. You'll really get their attention if you go in like that.
Okay, thank you.
I just want to say thank you for turning off SMB1 by default. It would be very bad if you shipped with that turned on by default.
So you mentioned it was very awkward for the ES Fileops Explorer application, which was SMB1.
Yeah.
Why is that a problem? Is that like a Samsung product problem or something like that?
As you know, ES5 browser is very famous application for SMB client, and so I think that I tested another application. So I cannot remember some application name, but other applications supported only SMB version 1 still. So so and
okay. So this gets to a discussion Jeremy and I were having a little while ago today.
We need more SMB3 clients out there. Just real quickly, that this is what I was talking about before, that the eStrong's client piece uses JCIFS, so it's outdated. And since they don't, the only Java client that does SMB2 is commercial, so they haven't picked it up apparently.
That got me thinking a little bit about the visibility of some of the other SMB clients.
Yeah.
I was talking to Ronnie Sahlberg, who couldn't be here.
Yeah.
Ronnie was super excited about the new client improvements for the libSMB2 actually, but it's SMB3. And just an FYI, so whenever you're doing library work, there is really good library support that Ronnie's improved. So he is very excited about that. He couldn't present here, but in terms of other SMB3 clients, you have SMB client libraries in Samba, you have the kernel client, you have some closed source clients, but you also have the libSMB stuff that Ronnie has done. The other thing I wanted to ask you about was automated testing. Obviously we'd love to have the build bot updated with running regular tests against the cifsd server and NetApp servers and other servers to make sure the kernel client doesn't regress mounting against this server. I think the other thing that Jeremy and I would love to talk about, maybe offline, maybe after this, is POSIX extensions, and make sure that for kernel developers who maybe aren't familiar with SMB3 stuff, that we support enough of the POSIX extensions pretty quickly to make sure that they get a good user experience, with mode bits and this sort of thing. It's not absolutely essential because there aren't a lot of deployment yet with that, but I think it's important because part of the value of this is getting visibility to people outside this room, outside the Samba community, because having the kernel server makes it really easy for people who are like, I don't know how SMB works. I don't know. How do I test this? And I think this is of a lot more value than you might think in getting visibility out, but maybe offline we could talk about the POSIX extensions.
Thank you. Any more questions? Yeah.
How do you do the authentication and user database things? And is it possible to join a domain or something like that?
Sorry, pardon? Yes.
The question is, how do you authenticate a user session? And where are the user accounts stored?
User account is stored in DB5. So using cifsd admin util. So, and cifsd, user space cifsd is user account and password information to kernel using netlink.
Okay. Yeah. And is it possible to join a Windows domain with Active Directory?
Domain?
Yeah, Active Directory domain. You don't join that.
Yeah.
I think I need password configuration.
Yeah. Yeah.
Okay.
You also show NTLM. Really?
Yeah.
No? Okay.
Yeah, NTLM, yeah.
Why do you support NTLM?
Yeah.
Raw NTLM, not V2.
Domain name is from SMBconf. Yeah, so when users store domain name in SMBconf and cifsd, user space cifsd is read the SMBconf and to get domain name and send it to kernel.
Okay, that wasn't totally my question, but you're using some known insecure protocols here. So, NTLM was cracked years ago. NTLM v2 is barely any better. SMB1 is persona non grata in just about every place in the world, except, I guess, So I think there will be some significant security hardening required.
Okay.
SS is basically for a NAS, a small NAS device. You only have a router. On the router, you need a file with user and password, and you will not roll out Active Directory on that. Yeah. Yeah, but I mean, with Kerberos, you need Active Directory infrastructure. And
actually, I was going to say I wouldn't make that assumption because there may be investments like an IoT, and guess where they run?
Anyone else? If there are no questions anymore, we have a little break again to refresh. And thank you very much for your presentation. I have a little gift for you.
Thank you.